that we add 1 multiplied by 1/3, it's going to be negative 1/9 x cubed. Now this one, 2/3 times something x to the plus 1 is 2, 1/2, it cancels. Plus 1, is it 2/3? X minus 1/3 is 2/3. Okay, so it's going to be plus 1/3 x squared. And then the integral of 1, the constant is just x. We're going to evaluate from 1 to 3. Equals pi times negative 1/9 times 3 cubed is 27 minus 1 is 26. Plus 1/3 times 9 minus 1 is going to be 8. Plus, that's 3 minus 1 is going to be 2. That's going to equal negative 26 over 9 plus 8 over 3. 8 over 3, if you multiply by 9, it's going to be 24 over 9 plus 2 is going to be something as 18 over 9. So 18 over 9 times pi, of course. Just really tedious math. I should have done this on a calculator. I should get the same exact answer. So that's going to be negative 2 plus 18 is 16. So it's going to be 16 pi over 9. Is it right? Ooh, woohoo! It was, I looked in the back of the book, the answer was 16 pi over 9. It's extremely tedious on this one, so make sure you can kind of see a little bit better now. Here we go. Make sure you work on this. You can, at this stage right here, you can use your calculator so that you don't make any erroneous errors, okay? 18 minutes has elapsed so far. We're going to do problem number 3. This is in parametric equation. X is equal to t, y is equal to 2t squared. And there's two ways you can do this. You can use parametric equations, manipulate the surface area formula, or you can change it, try to change it into x's and y's without the parameter t. Which way did I do it? I think I did it both ways, but I found one easier to the other. So let me get out my third page of notes on that. Let me see, page 1, page 2, where's page 3? Is it here somewhere? Should be here somewhere. No, it's not here. Let me see if it's this one. What is this? That's number 25. Okay, I can't find it. We'll just do it from scratch. Oh, I hate doing these from scratch. Okay. Since we're revolving around the y-axis this time, it's going to be dy on the back, the square root of 1 plus dx dy instead of dy dx squared times, instead of the radius is going to be your x. I'm going to integrate it from a to b of 2 pi. And that's going to be your formula for your area. Excuse me, let me put that down just a little bit. Here we go. So the area is going to be 2 pi integration from a to b of x, square root of 1 plus dx dy quantity squared. Since I have parameters, I can eliminate one of the parameters. The parameter, the independent variable at this time is t. The dependent variables are x and y. So dx dy is the same thing as a function of y this time. That's what I'm looking for. So in this situation, y, solving for t right here, t is equal to y over 2 and the square root of that. I divide it by 2, take the square root, that's how I solve for t. I'm going to plug it into here. So x is equal to, excuse me, as a function of y, x is going to equal square root of y over square root of 2. Okay, so far so good. Now I'm going to have to take the derivative of that. Instead of calling it x, I'm going to just call it f prime. Square 1 over root 2, that's a constant. Square root of y, if you take the derivative of that, you should know that by now. It's going to be times 1 over 2 root y. And so you're going to end up with f prime is equal to 1 over 2 radical 2 y. We're going to square it again because we have to square it on top. Square the left side, square the right side. Excuse me, so f prime squared is equal to 1 over 2 root 2 is going to be 1/8. That's the square root of y right there. Square root of the square is going to be y, so it's going to be 1 over 8y. We still have to do this portion right here. So we're going to add 1 to the left side. 1 plus that. Add 1 to the right side. It's going to be 8y over 8y plus 1 is 8y plus 1 all over 8y. It's equal to 1 plus f prime squared. And the last thing we're going to do with that is we're going to square root it. And in the numerator, you're going to have square root of 8y plus 1 all over 2 root 2 and then square root of y. I'm going to keep it like this because it's going to cancel with some of them as we create the equation. So the surface area is equal to 2 pi. Now this is where it gets a little bit tricky. What's the limits of integration? Where's a? A is going to start at 0, so I'm going to label this a right here and label this b. But it's in terms of dy, so we have to use the y function right here. When a is 0, or t, the initial value, where t is 0, then my y value is going to be 0. When is it from 0 to 4? Let me just look at the problem one more time on number, what was that, 23. 23? Ooh, yeah, that's a big problem. Yeah, that's what I thought. First time I did it, I made a mistake. It's from t equals 0 to 1, right there. Not 4, please. So when you plug in 1 squared is 1 times 2 is 2. And then your x value, my x value was square root of y over 2, square root of y over square root of 2, times, now this portion, square root of 8 y plus 1 over 2 root 2 square root of y. Notice that the square root of y is cancel. It's always dy this time. The 2's also cancel. And square root of 2 times square root of 2 is 1 over root 2. That becomes pi over 2. Integration from 0 to 2 of square root of 8y plus 1 dy. We paid the price up front. Hopefully, the problem should be a lot easier to solve now. Remember, you can't do this in your head for most of you. Even I can't do this in my head. So make sure you write every single step down before you start. We're gonna, at this stage, we're gonna use the u substitution. We're gonna let u equal 8y plus 1. So du is equal to 8 dy. I have a dy here. Get rid of the 1/8 by multiplying by 1/8. So the 1/8 comes out in front. It's going to be pi over 16 because pi over 2 times 1 over 8 is 1 over 16. And we're going to change the limits of our integration. I'm going to do this in, let's see, have you tried blue, pink, orange? Okay, we tried all of them. Starting at 0 here, when y is 0, it's going to be 1. And then let's use blue this time. At y equals 2, that 16 plus 1 is going to be 17. So we're going to change the limits of integration so that we don't have to back substitute. Pay the price up front so that you don't have to do it in the back. This becomes square root of u du. That was our u, and then du is equal to 1/8 dy, and then factor it out. So what do you do from here? That's going to be u to the 1/2. Integration of that is going to be u to the 3/2 and times 2/3. So it's going to be pi over 16 times 2/3 times integral. Now we just integrated that. It's going to be u to the 3/2 and evaluate it from 1 to 17. Cancel this out, becomes 8. So pi over 24 times 17 to the 3/2 is the same thing as 17 times square root of 17. If you're not familiar with this, try to change it into radical form. It should not be 17 root 17. 17 radical 17 minus 1, because the cube root 1 to the 3/2 is, I'm going to work it out for you, is the square root of 1 cubed. That's how you change it to radical form. The denominator becomes the index. The numerator of the exponent comes to the outside. Square root of 1 is 1. Obviously, to the 3 power is 1. I think that's the answer. Yeah, I can't see the answer, so seems to be right. Okay, so there it is. The last problem, it's a little bit difficult. First time I tried it with my student, I missed an R somewhere. So let's try to figure this out. This is problem number 28. So you have two parametric equations, x equals r cosine of t, y equals r sine of t, show that the area of a sphere, the surface area that is 4 pi r squared. As I stated earlier, you're given this formula in geometry. I also teach honors geometry to about 7 students, and they're actually given this formula all the time. So this time we're going to prove it. It's a proof. Okay, I'm going to prove it out using calculus. So let's get started. We're revolving around before we start though, how do we know that this is the equation of a circle? We know that the sine squared of t plus the cosine squared of t, that's the Pythagorean theorem, in trigonometric form is always equal to 1. Solving for cosine of t is equal to x over r, sine of t is equal to y over r. So cosine sine squared of t is y over r quantity squared plus x over r quantity squared is equal to 1. Y squared over r squared plus x squared over r squared is equal to 1. Multiplying both sides by r squared, x squared plus y squared is equal to r squared. And we know that from geometry to be the equation of a circle. So it's in the parametric form.